November 24, 1944, from North Field on Tinian and Isley Field on Saipan, the 21st Bomber Command sends out 111 Boeing B-29 Superfortresses toward Japan. In Guam, Brigadier General Haywood Hansell directs the American Strategic Bombing Force from his headquarters. The giant silver bombers are loaded with 277 tons of bombs, their target being the Nakajima Aircraft Company's Musashino engine plant on the outskirts of Tokyo. What Japanese pilots are about to see this morning will completely change their understanding of aerial combat. They will discover a level of technology that courage alone cannot defeat. At Chofu Airfield outside Tokyo, Captain Tatsuo Yamada adjusts the straps of his oxygen mask inside the cockpit of his Kawasaki Ki-61 Heian fighter. That morning's briefing stressed the importance of intercepting the enemy bombers from as high an altitude as possible. Reports from intelligence warned of large four-engine bombers flying from the recently captured Mariana Islands, operating at heights never seen before. Yamada steps forward to volunteer for this dangerous high-altitude interception mission. He knows the fight will be tough, as the true strength of the American aircraft is still unknown. His Ki-61 is armed with 4 12.7mm machine guns and 2 20mm cannons, weapons well suited for dogfights at normal altitudes, where Japanese fighters usually had the edge. But the challenge here is different. Japan's experience against heavy American bombers had mostly come earlier in 1944 over China. At that time, B-24 Liberators and older B-17 Flying Fortresses operated at heights Japanese planes could still reach, usually around 20,000 to 25,000 feet. From those encounters, Major Teiichi Mita had developed special climbing tactics. His strategy was clear: gain altitude before the battle, not during it. A fighter that already held the high ground had more speed and energy to cut through the bombers' defenses, but this morning's reports warned that these new bombers were flying at altitudes higher than anything Japan had ever faced. The 21st Bomber Command represented the most powerful strategic air force America had deployed in the Pacific since the Doolittle raid of 1942. Eventually, it would field over 1,000 aircraft from 5 major air bases on Saipan, Tinian, and Guam. These new B-29s had pressurized cabins, designed specifically for extreme high-altitude missions across the vast Pacific. The B-29 was built with a completely different philosophy than earlier American bombers. Aircraft like the B-17 Flying Fortress and the B-24 Liberator had unpressurized crew compartments. Their crews had to wear heavy flight suits and rely on oxygen masks, which limited their maximum effective altitude to around 25,000 feet. With the B-29, American designers took a new approach. They put altitude capability first, even though it meant making the aircraft far more complex. In return, the crews gained an enormous advantage. They could fly high enough to avoid most enemy interceptors. Thanks to the pressurized cabin, airmen could work in comfort, wearing only their normal uniforms, even at heights where unpressurized crews would be freezing and fighting for breath. Captain Tatsuo Yamada flies with a formation that includes Ki-61 Heian fighters from the 244th Sentai and Nakajima Ki-44 Shoki interceptors from the 47th Sentai. From airfields scattered around Tokyo, these squadrons climb at maximum effort to meet the threat. As they struggle upward, the Japanese pilots spot long white contrails forming far above them. The American bombers are approaching from the southeast at extreme altitude. At the Chiba radar station, operators detect the incoming force. Their reports place the B-29s between 27,000 and 31,000 feet, adjusting height as they move through shifting weather. Ground controllers scramble to vector Japanese fighters into their path, but the problem is immediate. Most interceptors cannot climb higher than 25,000 feet before the bombers arrive overhead. The technological gap becomes clear the moment the two sides engage. Yamada is flying an aircraft designed back in 1941 for mid-altitude combat against Chinese forces and early war Allied planes. His Ki-61 weighs 7,650 pounds, powered by a Kawasaki Hei-40 liquid-cooled engine producing 175 horsepower. On paper, the Haiyan could reach speeds of 368 mph at 16,400 feet and had a service ceiling listed at 36,000 feet. In practice, however, performance dropped off sharply above 28,000 feet. The engine lost power in the thin air, and the controls became heavy and sluggish. Combat experience had forced designers to add self-sealing fuel tanks and armor for the pilot, which made the plane heavier and further reduced its high-altitude ability. Meanwhile, the Ki-44 Shoki interceptors of the 47th Sentai, aircraft specifically intended for high-altitude interception, also struggled. They climbed aggressively toward the bombers, but their engines overheated and produced only a fraction of their rated power at such heights. Oxygen systems were not built for extended fighting so high up, and pilots found themselves gasping for air. Most fighters reached only about 28,000 feet before their performance collapsed, still thousands of feet short of the highest bombers. Those few aircraft that did claw their way higher had almost no energy left to fight. Their controls barely responded, and their engines screamed at the limit of their design. Above them, the B-29s pressed on in tight formation. The American crews worked calmly in their pressurized cabins, free of the heavy gear that burdened earlier bomber crews. Leading the group was Captain Robert Morgan in the Superfortress Dauntless Dottie. His navigator, Captain Theodore Van Kirk, guided them toward the Musashino target using the advanced Norden bomb sight. The B-29's four Wright R-3350 engines, each producing 2,200 horsepower, drove the bomber through the thin air at over 300 mph. Turbo-superchargers maintained full power even at extreme altitudes, something Japanese engines could not achieve. The bomber's pressurized sections were linked by a tunnel running above the bomb bays, so crew members could move between compartments without cumbersome altitude suits. For defense, the central fire control system used analog computers to direct multiple gun turrets at once, letting gunners track and fire on several attackers simultaneously from the safety of pressurized positions. As Yamada forces his Ki-61 to its absolute ceiling, his airspeed drops to barely 180 mph. His aircraft shudders and wallows in the thin atmosphere, struggling desperately to reach the bombers cruising above 30,000 feet. Captain Yamada's pre-war training had never prepared him for combat at such extreme altitudes. The morning briefing had instructed pilots to attack from above with diving passes to maintain speed and energy. But in reality, getting above the B-29s proved impossible. Japanese air doctrine had been shaped by fighting unescorted B-17s and B-24s at moderate heights. Against the new American bombers, those tactics were useless. Yamada manages to hold 30,000 feet for only a few seconds before his Haiyan stalls, dropping 3,000 feet as he recovers. Each attempt ends the same way. His engine temperature surges past redline, oil pressure wavers dangerously, and still the bombers remain out of reach, looking up. Yamada watches the contrails of the formation as the massive aircraft sweep overhead. Their defensive guns track his movements, but at such range they do not fire. The gap in altitude makes any kind of engagement nearly impossible, no matter how determined the Japanese pilots are. That morning, only about 40 Japanese fighters managed to close on the bomber formation. Most can do no more than a single firing pass before they run out of energy and stall away. Climbing gunfire is ineffective. In the thin air, machine gun rounds lose speed quickly and many fall short of their targets. The handful of fighters that do reach firing range can only manage brief bursts before slipping back down through the sky. Anti-aircraft fire fares no better. Guns pound away, but their shells explode thousands of feet below the bombers, even at maximum elevation settings. The heaviest anti-aircraft weapons in Japan's arsenal could theoretically hit 30,000 feet, But at that height, accuracy is nearly non-existent. November 24th marks history, the first mass B-29 strike on Tokyo since the symbolic Doolittle raid 31 months earlier. The formation presses on toward the Nakajima Aircraft Company's Musashino engine plant, the heart of Japan's aircraft engine production. At the lead, Chief Bombardier Lieutenant Coleman drops his bombs on signal, followed in sequence by the other aircraft. Yet a new challenge appears: powerful jet stream winds, blasting at over 200 mph. Because of this, only 24 bombers strike the primary target, while the rest either miss or hit secondary objectives. Even so, the effect is stunning. For the first time, bombs rain down on Tokyo from altitudes beyond anything the Japanese believed possible. On the ground, civilians and soldiers alike watch white vapor trails stretch across the sky, far above the reach of interceptors. At sector control, Lieutenant Kenji Tanaka listens to frustrated radio calls from fighter squadrons. Pilots report engines overheating, controls becoming sluggish, and an inability to hold the necessary height for interception. Despite their best efforts, most fighters burn fuel climbing in vain, then return to base without ever firing a shot. The bombers suffer only one loss that day, destroyed by a ramming attack from a crippled Japanese fighter whose pilot sacrificed himself in desperation. In return, B-29 gunners claim 5 Japanese aircraft destroyed. Several American bombers do suffer mechanical problems, forcing them to divert or ditch into the Pacific. But overall, the 21st Bomber Command completes its first Tokyo mission with minimal losses. For Japan's defenders, the shock is overwhelming. The altitude sanctuary of the B-29 defies every assumption based on earlier fights against lower-flying bombers from China. The failure exposes a fundamental misunderstanding of American capabilities and highlights the revolutionary design of the Superfortress. At Naval Headquarters, Lieutenant Commander Minoru Genda studies reports of the raid. As he reviews the Army fighters' failures, his concern grows. He realizes Japan is facing a weapon unlike anything it has encountered before. Lieutenant Commander Minoru, Genda's intelligence reports highlight the most alarming fact. The B-29s are operating at altitudes far beyond the reach of Japanese interceptors. Even the Navy's newest fighters cannot effectively engage the Superfortress at those heights. Strategically, this means Japan would need completely new aircraft designs or entirely different defensive measures. But time and resources are already running out. The root of the problem is a lack of understanding. Japanese analysts had little technical knowledge of America's pressurization systems and turbo-supercharged engines, the very innovations that made true high-altitude warfare possible. Instead, their planning had been based on earlier encounters with American bombers over China. Those aircraft, the B-17s and B-24s, usually flew below 25,000 feet, well within reach of Japanese fighters. Because of this experience, military leaders assumed the same would hold true for the new bombers. The revolutionary pressurized cabin of the B-29 and its implications for combat were not properly understood. On December 3, 1944, another major B-29 raid strikes Tokyo. This time, 86 bombers once again target the Musashino engine plant. The Japanese response is shaped by lessons learned from the November disaster. Captain Teruhiko Kobayashi of the elite 244th Sentai orders new tactics. His fighters will be placed at their maximum altitude before the bombers arrive, hoping to dive down with the advantage of speed and energy. Yet even from this improved position, the Ki-61 high-end fighters still cannot climb to the bombers' level. Some aircraft are specially modified, stripped of radios, armor, and even most of their ammunition to reduce weight. These lightened versions manage to climb a little higher, but remain short of the altitudes needed for a true interception. Alongside them, Lieutenant Saburo Hayashi leads a newly formed ramming unit called the Hagakure Tai. This special group is made up of volunteers prepared to sacrifice themselves. Their Ki-61s are stripped to the bare minimum, no extra weight, hardly any armament, and just enough fuel for a one-way mission. The goal is simple: reach maximum altitude, then collide with the enemy bombers. To achieve even this, pilots push their machines far past safe limits. Engines are run on emergency boost, manifold pressures climb well beyond manufacturer recommendations, and cylinder head temperatures near the breaking point. Before takeoff, the men breathe pure oxygen for 30 minutes. But once airborne, their inadequate systems still leave them lightheaded and struggling with hypoxia as they climb higher. Most fighters stall around 30,000 feet, still beneath the bombers. But one pilot, Sergeant Masayuki Itagaki, manages to reach 31,500 feet in his stripped-down Ki-61. Spotting the straggling B-29, he pushes into a zoom climb for a desperate ramming attack. The bomber's gunners open fire, their .50 caliber rounds tearing into the approaching fighter. Holes rip across the Ki-61's fuselage and wings, but Itagaki holds course, forcing his damaged aircraft upward. At the last moment, his plane loses speed and stalls a mere 500 feet below his target. Out of control, the fighter drops into a spin, plunging away from the American formation. Sergeant Itagaki manages to recover his damaged Ki-61 at 20,000 feet, but with too little fuel and a crippled aircraft, another climb is impossible. The ramming attacks occasionally succeed, usually when a B-29 is forced to descend because of mechanical trouble. But as a systematic defense, they cannot stop the high-altitude raids. Through December 1944, losses among the superfortresses remain minimal, while Japanese cities begin to feel the destructive impact of America's new strategic bombing campaign. For the defending pilots, frustration grows unbearable. They watch their homeland burn from above, yet remain powerless to intervene. Their warrior spirit, traditional code of the samurai, means nothing against a barrier of technology that prevents them from even reaching the enemy. Many report deep feelings of helplessness and shame, frustrated that even their willingness to die cannot overcome the Superfortress. In January 1945, Major General Curtis LeMay takes command of the 21st Bomber Command. Known for his relentless focus, LeMay quickly studies the results of the high-altitude daylight raids. The findings are grim. Accuracy is poor. At bombing altitudes, newly discovered jet stream winds, sometimes over 250 mpg, push the bombers off course. Bombs drift miles from their intended targets, no matter how skilled the bombardier. Navigation becomes more difficult, and during the winter months, thick cloud cover forces crews to rely on radar bombing, which delivers even less precision. The statistics are alarming. Fewer than 10% of bombs are landing on their assigned targets. In Washington, pressure mounts for better results. LeMay responds with a bold and controversial solution. In March 1945, he orders a complete change of tactics: low-altitude night incendiary attacks against Japanese cities. The transformation is dramatic. The B-29s are stripped of almost all defensive guns except for their tail armament, allowing them to carry maximum loads of incendiary bombs. Instead of flying at 30,000 feet, they descend to altitudes between 5,000 and 9,000 feet. This eliminates the jet stream problem, but also places them squarely within range of Japan's air defenses. The shift changes everything. Suddenly, Japanese fighters are able to reach the bombers without the impossible altitude climb. The balance of combat alters overnight. On March 9, 1945, the new strategy is put into action in Operation Meeting House, the firebombing of Tokyo, the single most destructive air raid of the war. That night, 334 B-29s roared toward the capital at 5,000 to 9,000 feet. At Matsudo Airfield, Lieutenant Yoshio Mitsuyoshi scrambles in his Nakajima Ki-44 Shoki. For the first time, he can climb directly into the bomber's path without difficulty. The Japanese defenders finally have their chance to strike, but night combat brings an entirely new set of problems. Without airborne radar or reliable ground control, Japanese fighters find it nearly impossible to locate their targets in the dark skies. Searchlights sweep upward, briefly locking onto bombers one at a time. While anti-aircraft gunners fire at point-blank range for the first time, Ki-44s and Ki-61s launch desperate solo attacks, each pilot operating without radio coordination or formation support. Lieutenant Yoshio Mitsuyoshi manages to make several firing passes against the massive B-29s, watching his rounds strike engine nacelles and fuselages. Some bombers trail flames and lose altitude, but astonishingly, most continue pressing toward Tokyo despite their damage. The durability of the Superfortress shocks Japanese defenders. Even after absorbing heavy punishment, the B-29s hold formation and proceed to their targets. Remote-controlled turrets, guided by radar even in the darkness, prove deadly effective against the attacking fighters. Trained almost exclusively for daylight combat, Japanese pilots struggle to adapt to the chaos of night fighting. Meanwhile, the attack below unleashes devastation unlike anything seen before. The incendiaries ignite a firestorm that engulfs 16 square miles of Tokyo, killing an estimated 100,000 civilians in a single night. The deadliest air raid in history. Japanese fighters claim 14 B-29s destroyed, their highest success of the war. But they cannot stop the catastrophic destruction of the capital. The low-altitude tactic allows interception, but overwhelming bomber numbers the cover of night. And the surprise of the new strategy leave Japan's defenses largely ineffective. For General LeMay, the success validates his gamble. The firebombing of Tokyo sets the pattern for the raids that follow. This tactical change also renders months of Japanese development useless. Entire programs devoted to creating high-altitude interceptors, advanced engines, and pressurization systems suddenly have no purpose. Overnight, the focus of air defense is turned upside down. Among Japan's newest fighters is the Mitsubishi J-2M Raiden, flown by Imperial Navy Lieutenant Sadamu Kumagai during raids over Nagoya in early 1945. On paper, the Raiden's supercharged Kasei engine gives it a service ceiling of 36,000 feet, high enough to meet the B-29s. But in practice, fighting at those heights proves almost impossible. Even when a Raiden reaches bomber altitude, the controls become heavy and unresponsive. The engine struggles in the thin air despite its supercharger, leaving the aircraft with little power to maneuver. Pilots report that they cannot hold proper pursuit curves or lead bombers effectively. At best, they can attempt a single firing pass, but only if they are already perfectly positioned before the formation arrives. Once the bombers pass overhead, chasing them from below is hopeless. Oxygen systems often fail, causing pilots to grow dizzy or even lose consciousness at extreme altitudes. Most successful interceptions occur only against damaged stragglers falling out of formation, not against the intact bombers cruising at operational height. By April 1945, as conventional interception continues to fail, Japan turns increasingly to desperation. Special attack units are formally organized, with kamikaze pilots assigned specifically to target the B-29s. On April 12, 1945, Corporal Koshi Ogawa carries out a successful ramming attack against a B-29 nicknamed Torchi over Kawasaki. Both aircraft are destroyed in the collision. That same day, one of the most celebrated acts of bravery in B-29 operations takes place. Staff Sergeant Henry "Red" Irwin, serving as a radio operator, suffers a horrific accident when a phosphorus flare ignites prematurely inside his bomber. The device explodes in his face, burning through his skin, destroying his nose, and blinding him instantly. Engulfed in flames, Irwin somehow finds the strength to pick up the blazing canister and stagger through the fuselage, carrying it past his crewmates. He finally hurls it out of the cockpit window, saving the lives of all 11 men aboard. For this act of unimaginable heroism, Irwin is awarded the Medal of Honor. His sacrifice highlights a striking truth about the air war over Japan. Both sides displayed courage and willingness to die, even as technology created an uneven playing field. By this time, Japan is formally organizing special attack units. Pilots volunteer for certain death missions against the giant silver bombers, determined to ram them out of the sky. These tactics achieve only limited success, perhaps 10 B-29s destroyed throughout the entire war, a minuscule fraction of the bomber fleet. Yet the psychological effect on American crews is undeniable. The thought of enemy pilots deliberately hurling themselves into their aircraft is a constant source of tension, even if the strategic impact remains negligible. Meanwhile, the B-29's technological edge continues to frustrate Japanese defenders. Its central fire control system is revolutionary, a computer-driven network of remote-controlled turrets that can track and fire on multiple targets simultaneously. Gunners, protected inside pressurized compartments, no longer need to expose themselves to the elements or enemy fire as they did in earlier bombers like the B-17. Japanese pilots report an unprecedented level of defensive accuracy. Even when bombers execute evasive maneuvers, the automated system maintains precise tracking. And unlike previous designs where a wounded gunner meant a blind spot in the bomber's defenses, the B-29's remote system keeps working even if one position is damaged. Combined with its ability to cruise at extreme altitudes, this technology creates a nearly untouchable fortress in the sky. But in April 1945, another turning point arrives. The US introduces P-51 Mustang escorts operating from bases on Iwo Jima. With their long range and superior performance, these fighters extend American air power deep into the heart of Japan. The result is decisive. Daylight B-29 missions become even safer, as Japanese interceptors must now fight not only the bombers but also swarms of aggressive escort fighters. Captain Yasuhiko Kuro, commander of the 64th Sentai, leads his men in Japan's newest frontline fighter, the Nakajima Ki-84 Hayate, or Frank in Allied code. It is the most advanced operational fighter Japan fields in 1945, faster and better armed than its predecessors, and one of the few aircraft theoretically capable of challenging the American Mustangs and reaching the Superfortresses. The Nakajima Ki-84 Hayate represents a significant leap in Japanese fighter performance. Under ideal conditions, it boasts a service ceiling of 34,450 feet. In practice, with reduced armament and minimal fuel, it can sustain around 32,000 feet. Pilots report solid performance up to 28,000 feet, but beyond that, the power of its Che-45 engine degrades sharply. Though formidable at medium altitudes, the engine lacks the advanced supercharging necessary for true high-altitude combat. Still, the Ki-84 proves dangerous in the right conditions. When American B-29s conduct mining missions at lower altitudes over coastal waters, Japanese pilots finally have the chance to meet them on more equal terms. In these engagements, the Hayate scores several victories against bombers flying below 20,000 feet. These rare successes highlight its capability, but only when the crippling altitude disadvantage is removed. Against daylight raids at 30,000 feet, the performance gap remains insurmountable. In June 1945, a new aircraft enters service, the Kawasaki Ki-100, born from Ki-61 high-end airframes, retrofitted with radial engines. It replaces the unreliable liquid-cooled power plants that had plagued earlier designs. The modification sacrifices some altitude performance but dramatically improves reliability. The Ki-100 quickly earns the respect of its pilots. At medium altitudes, it proves agile, responsive, and highly maneuverable, even capable of holding its own against American fighters. But with a ceiling of roughly 32,000 feet, it still cannot reliably reach the altitudes where superfortresses roam. For bomber interception, it remains inadequate. For fighter combat, it is Japan's best operational aircraft of the war. But it arrives too late, and in numbers far too small to change the outcome. Even as the skies above Japan burn with American raids, Engineers continue to pursue specialized high-altitude interceptors. The Mitsubishi Ki-83, a twin-engine heavy fighter equipped with turbo-supercharged engines, promises excellent altitude performance. The Kawasaki Ki-102 is conceived as a powerful bomber-destroyer, mounting heavy armament intended specifically to tear into B-29 formations. But these designs remain trapped on drawing boards and in prototype hangars. Severe shortages of critical materials, especially high-grade aluminum and special alloys required for supercharger production, cripple development. Allied bombing raids compound the problem, systematically targeting Japan's aviation infrastructure. In January 1945, the Akashi Engine Works, sole producer of the Hei-40 engine that powered the Ki-61, is destroyed in a devastating air raid. With factories and engine plants burning, Japan's ability to mass-produce advanced fighters collapses. By mid-1945, promising designs remain unflown or exist only as damaged prototypes, while American B-29s continue their relentless campaign with near impunity. By mid-1945, the technological gap between the United States and Japan had grown insurmountable. Each month brought new upgrades to the B-29, while Japan's aircraft industry collapsed under the weight of shortages and relentless bombing. Lieutenant Colonel Paul Tibbets oversaw a special training program to prepare crews for atomic bomb delivery. The modified silverplate B-29s carried no defensive weapons except a tailgun, allowing them to fly even higher than standard superfortresses. These stripped-down aircraft became completely untouchable in the skies above Japan. On August 6, 1945, the Enola Gay demonstrated this ultimate altitude sanctuary. Flying at 31,600 feet on its approach to Hiroshima, it triggered desperate interception attempts. Lieutenant Matsuo Yasui, climbing in his Ki-61, pushed his aircraft to the limit, reaching 29,000 feet before stalling, still 2,000 feet short of his target. Other fighters fared worse, most stalling out below 27,000 feet despite clear weather. The atomic bomb detonated while Japanese pilots circled helplessly below, unable to even grasp the nature of the weapon being used. 3 days later, on August 9th, the B-29 Boxcar carried out the second atomic strike against Nagasaki. Radar tracked the bomber throughout its approach, giving defenders advance warning. Multiple squadrons scrambled, but again, none could reach the aircraft's 28,000-foot altitude. The result was inevitable. The bomb was dropped without interference. Post-war studies revealed just how overwhelming the American advantage had been. Pressurized cabins allowed U.S. crews to work comfortably at altitudes where Japanese pilots could barely survive. Turbo-supercharged engines maintained power at 30,000 feet, while Japanese power plants produced less than half their rated output at the same height. No amount of bravery could close this gap. Japanese pilots showed extraordinary courage, but they were trapped by the limitations of their machines. High-altitude combat required engineering solutions beyond Japan's wartime industrial capacity. Lacking vital alloys and materials, they could never field competitive systems. The B-29 campaign proved the value of investing in cutting-edge technology and massive industrial output. Strategic bombing success depended on one thing above all: operational sanctuary through altitude superiority. This reality forced recognition at the highest levels of Japan's military leadership. During the final conferences before surrender, General Korochika Anami acknowledged that altitude advantage had rendered Japan's defenses meaningless. No matter how determined their pilots were, technical inferiority had erased their geographic and tactical strengths. That recognition helped push Japan toward acceptance of unconditional surrender. In post-war memoirs, former Ki-61 pilot Lieutenant Naoshi Kano recalled his own sense of helplessness. "We climbed with everything our engines could give, watching the gauges in the red. My leader's engine caught fire at 28,000 feet, and he bailed out. I pushed higher, reaching maybe 30,000 before my controls froze completely. The B-29s passed overhead like silver ghosts. We couldn't touch them. The shame of failing to protect our homeland was worse than the fear of death. From the other side, B-29 Technical Sergeant Robert Johnson described the view from his fire control station. We'd see them struggling upward, tiny specks getting closer. Sometimes we could make out their wings and the pilot's canopy. Then they'd stall, tumbling back down. A few fired at us, but their rounds always fell short. It was almost sad. They had courage, but we had altitude, speed, firepower, armor. Courage alone couldn't beat physics. The lessons of the B-29 shaped the future of air power. Strategic Air Command built its Cold War doctrine on high-altitude penetration, ensuring nuclear bombers would always operate above enemy defenses. Pressurization and turbo-supercharging advanced rapidly from this combat experience, eventually giving rise to jet-powered bombers flying at even greater heights. After the war, Japanese engineers studied captured B-29s and their documentation. They realized that American aircraft represented not just one step, but multiple generations of technological progress. The gulf in design, philosophy, and industrial capacity had defined the air war and sealed Japan's fate. The B-29's pressurization system represented an engineering achievement far beyond Japan's wartime industry. It required complex sealing mechanisms, synthetic rubber compounds Japan could not produce, and structural reinforcement demanding precision welding techniques unavailable to Japanese factories. Turbo-supercharged engines relied on high-grade alloys and manufacturing tolerances Japan simply lacked. Even the bomber's remote-control gun turrets used analog computers with vacuum tubes and servo mechanisms, technologies far ahead of anything in the Japanese arsenal. Veteran B-29 pilot Colonel Paul Tibbets later reflected on this advantage during the atomic missions. Flying above enemy fighter range meant we could focus entirely on navigation and the bomb run. We knew they could see us, track us on radar, but they couldn't touch us. It was like flying behind bulletproof glass. That sanctuary guaranteed success. From the other side, Captain Iwao Hayashi, flying the Ki-84 Hayate, recalled the near futility of his efforts. Even with Japan's best fighter, climbing above 30,000 feet was almost impossible. The engine sputtered, controls turned sluggish like moving through molasses. If we managed one firing pass, it was short and desperate, ending in a stall. Watching the bombers carry on while our cities burned below left us with a helplessness I'll never forget. Technical examinations of crashed B-29s only deepened Japan's frustration. Investigators found pressurized compartments with sealing systems and synthetic materials Japan couldn't replicate. Wiring insulation, electrical components, and structural alloys all exceeded Japanese standards. The precision of the remote turret computers and servo controls was unlike anything Japan could manufacture under wartime conditions. Major Toshio Sakagawa, who commanded the 244th Sentai, summed up his unit's experience. "My pilots were among the best in Japan, with years of combat behind them. Yet against the B-29s at altitude, we achieved almost nothing." Reports repeated the same story. Climb desperately to 28,000 or 29,000 feet, engines failing, controls useless, and then watch helplessly as the bombers passed overhead. The defeat was total and humiliating. B-29 bombardier Lieutenant Marcus McDilder also witnessed these attempts. Their determination was incredible. We'd watch them climb for 15 or 20 minutes, inching higher. Some tried zoom climbs, trading speed for altitude, firing a burst before stalling out and spinning away. Most never even got close enough for us to shoot. Our biggest protection wasn't armor or guns, it was altitude. That's what made the fight so one-sided. Japanese attachés in Germany had already reported that even the Luftwaffe, with superior engines and technology, struggled against Allied bombers above 25,000 feet. The German Me-262 jet achieved limited success thanks to its speed and altitude performance, but Japan had no way to develop equivalent technology. Attempts to copy German jet designs collapsed under material shortages and lack of expertise. The industrial and technological gap was simply unbridgeable. Colonel John Montgomery, leading the 9th Bombardment Group from Tinian, noticed the shift in Japanese tactics. At first, they threw everything they had into daylight interceptions, but by spring 1945 they'd practically given up at high altitude. Instead, they focused on our night raids when we flew lower. It was a smart adjustment, but it came too late. For most of the campaign, altitude gave us free rein to wreck their industry. Maintenance reports within the Japanese Air Force confirmed how badly altitude stressed their aircraft. Captain Hiroshi Fujiwara, a technical officer, documented the constant problems: engines overheating within minutes above 25,000 feet, oil pressure collapse, coolant boiling despite modifications, and oxygen systems failing, leaving pilots unconscious or worse. Frostbite was common as aviators removed gloves to adjust sluggish controls in freezing air. The evidence was undeniable. Japan's finest pilots fought with everything they had, but altitude and technology left them powerless. Mechanical breakdowns made sustained high-altitude operations nearly impossible for Japanese fighters, no matter how determined their pilots were. In contrast, B-29 crews operated in relative comfort. Staff Sergeant James Pearson, a flight engineer, described life aboard the Superfortress. At 30,000 feet, our cabin pressure stayed at a comfortable 8,000-foot equivalent. We worked in shirt sleeves, moving freely between stations. Meanwhile, Japanese pilots outside were freezing, fighting sluggish controls, gasping for oxygen, and flying engines that barely functioned. The mismatch was absolute. It wasn't a fair fight. It was hardly a fight at all. On the ground, Japanese radar crews could track American bombers easily. Corporal Shigo Yamamoto recalled the experience with bitterness. Our radar could pick them up hundreds of miles away, and we vectored fighters toward intercept points. But warning meant nothing when our planes couldn't climb to their altitude. Pilots would call in at maximum height, usually 27,000 or 28,000 feet, and report the bombers still above them at 31,000. The frustration in their voices was heartbreaking. We had the will, but not the means. Final wartime assessments within the Japanese military admitted outright failure to defend against B-29 high-altitude operations. Despite Japan's geographic position, its warrior ethos, and early warning radar, technological inferiority made defense impossible. The industrial limitations of wartime Japan meant there was no path to matching American bomber technology. That recognition weighed heavily in surrender discussions, as leaders understood continued resistance would not prevent national destruction from the air. The futility of Japan's last efforts was embodied by Lieutenant Kunyohi Tanaka. On August 14, 1945, just hours before surrender, he launched in a Kai-100 to intercept an American reconnaissance B-29 photographing bomb damage. His aircraft struggled to 28,000 feet before engine power faded, forcing him into descent. The American bomber cruised unopposed at 35,000 feet, completing its mission. That final, unchallenged flight symbolized Japan's enduring inability to counter American air superiority, even in the war's closing moments. From the American perspective, radio operators often overheard the struggle. Sergeant William Ale recalled, "We could hear Japanese ground controllers vectoring fighters toward us, giving altitude and heading instructions. Then the pilots would come back saying they couldn't climb any higher, engines overheating, power dropping away. Sometimes their voices carried anger, sometimes resignation. Either way, they couldn't reach us. Japan's fighter force had courage in abundance, but without the technology, altitude turned their efforts into hopeless climbs against an unreachable enemy. They knew where we were, knew what we were doing, but they couldn't stop us. Technology determined everything. The United States Strategic Bombing Survey later confirmed this truth through exhaustive analysis of Japan's air defense efforts. Across the entire campaign, high-altitude daylight B-29 raids suffered minimal losses to enemy fighters. Out of more than 30,000 sorties, only about 50 bombers were destroyed. In aerial combat, a loss rate of less than 0.2%. Japanese interceptors proved effective only when circumstances forced B-29s to descend due to mechanical troubles or tactical changes. Otherwise, the altitude sanctuary rendered Japan's air defenses nearly irrelevant. Former Imperial Navy Commander Masatake Okumiya admitted in post-war assessments that intelligence had underestimated the Superfortress from the very beginning. We believed the maximum altitude capability to be around 26,000 feet, based on American B-17 and B-24 performance. When the B-29 operated above 30,000 feet as a matter of routine, our entire defensive strategy collapsed. We lacked the time, the resources, and the technology to develop an effective countermeasure. For American crews, that disparity translated into an enormous psychological edge. Colonel Robert Robbins, a B-29 pilot, recalled, "Knowing the enemy couldn't reach us changed everything. We flew straight and leveled to the target, no evasive maneuvers needed. Bombardiers had steady platforms, gunners stayed calm, and the only real danger was mechanical failure. Above 30,000 feet, we owned the sky, and everyone knew it. From the Japanese side, the effect was crushing." Veteran Ki-44 pilot Captain Yoshiro Aoki described the helplessness of watching contrails far above him. Every mission was the same humiliation. We climbed until our engines failed, reaching perhaps a third of the needed altitude. Then we'd look up and see silver lines stretched across the sky, untouchable. Our warrior spirit meant nothing against aluminum and engineering. We were samurai with swords trying to reach the moon. The psychological damage to morale proved more devastating than actual combat losses. General Henry Hap Arnold, commander of the U.S. Army Air Forces, evaluated the B-29 program after the war. Despite development costs exceeding even those of the Manhattan Project, he declared it a decisive success. The altitude sanctuary justified every dollar. It enabled precision bombing and atomic weapon delivery without prohibitive losses. It proved that technological superiority could achieve victory without massive ground invasions. The investment in pressurization, turbo-supercharging, and defensive systems shaped the future of aviation. Japanese aircraft designer Takeo Doi, who had worked on the Ki-61, later analyzed its failure against the B-29. Our fighter was optimized for 15,000 to 25,000 feet, where aerial combat usually occurred. We never anticipated a bomber that could cruise comfortably above 30,000 feet. By the time we understood the requirement, it was far too late. The lessons were written in the sky itself. Altitude was not just a number, but the very boundary between survival and defeat. Modifying existing aircraft proved impossible. The engines, airframes, and systems were simply unsuited for extreme altitude. Starting from scratch would have taken years we didn't have, and resources that no longer existed. Squadron leader Major Teruhiko Kobayashi of the 244th Sentai had scored more than 100 victories against American aircraft, but his success did not extend to the B-29. My pilots included multiple aces with years of experience against fighters and medium bombers, he later said. We remained competitive in many fights, but B-29s at altitude might as well have been on another planet. Skill counted for nothing when your aircraft physically could not reach the enemy. We watched our homeland burn while having the will, but not the means, to defend it. From the bomber side, the advantage went beyond simply flying higher. B-29 Navigator. Lieutenant Thomas Cartwright explained how pressurized cabins improved every aspect of the mission. Working at altitude without heavy oxygen masks or bulky gloves let us perform precise chart work and calculations. We could use all our instruments, talk clearly, and move between stations as needed. Japanese navigators in unpressurized fighters dealt with fogged goggles, frozen instruments, and hypoxia that clouded judgment. Our technological edge multiplied our effectiveness in ways that went far beyond altitude alone. On the ground, Anti-aircraft artillery fared no better. Colonel Hiroshi Yamamoto, who commanded heavy AA units, recorded the futility of trying to stop bombers from the ground. Our largest guns could theoretically reach 30,000 feet, but accuracy at that height was almost impossible. Shell dispersion meant hitting anything required incredible luck. We fired thousands of rounds for each bomber destroyed and drained our ammunition without meaningful effect. The B-29s flew above effective ground defense capability, protected by altitude as surely as if they wore armor. Maintenance troubles accelerated the collapse of Japan's interceptor force. Engines needed complete overhauls after just a few maximum altitude attempts. Supercharger systems failed regularly, and replacement parts became harder to find. Oxygen systems demanded constant attention, but supplies of oxygen bottles and CO2 absorbents ran low. Mechanical attrition reduced available aircraft long before combat losses did, creating a downward spiral of capability. From the tail of a Superfortress, Sergeant Robert Goldsborough had a front-row view of Japanese attempts. From the tail, I could see them as tiny specks growing larger as they climbed. Some fired from extreme range. Their tracers arched up and then fell short. Others tried zoom climbs, trading speed for altitude. They'd hang there for a moment, almost close enough, and then stall and tumble away. I rarely fired. They were never a real threat. The mismatch wasn't just altitude. It touched every aspect of aerial warfare. Indeed, the technological gap included navigation, communications, and basic equipment. B-29s carried radar and radio navigation aids Japanese forces did not possess. Their communications allowed coordinated operations over hundreds of miles, while Japanese radios often failed. Even seemingly small items, heated flight suits, optical gun sights, reliable wiring insulation, reflected American industrial depth. Japan simply could not match US production. B-29 manufacturing used precision techniques, strict quality control, and assembly line economies of scale impossible to replicate under Japanese wartime conditions. America built nearly 4,000 B-29s, while Japan struggled to produce only hundreds of fighters, most of them inferior by comparison. Attempts to copy captured components failed because Japan lacked access to the special alloys, synthetic materials, and precision tools needed for advanced aircraft. The industrial technology gap proved insurmountable given wartime resource limits and the steady destruction of factories. On the front lines, Lieutenant Commander Masahiko Kawamoto led special attack units against B-29 formations over Nagoya. "We tried everything: night attacks, dawn interceptions, coordinated ramming strikes," he said. Nothing worked consistently. The B-29s adapted faster than we could, changing altitudes, routes, and tactics. When we developed night interception techniques, they switched to high-altitude daylight raids we couldn't reach. They held every advantage. We had only determination. All of this came down to design. Boeing built the B-29 specifically for strategic bombing in the Pacific Theater. Its extended range allowed operations from distant bases, putting the bombers beyond effective enemy interdiction. Every aspect of the airplane, pressurization, turbo-supercharging, remote fire control, and robust construction, was tailored to the mission as striking Japan from a sanctuary of altitude. Pressurization allowed the B-29 to operate routinely at altitudes beyond the reach of enemy interceptors. Its defensive systems offered strong protection without compromising speed or performance. The design philosophy was clear: prioritize technological superiority over traditional bomber traits, turning the aircraft into a true weapon system rather than just another airplane. After the war, lessons from the B-29 shaped aviation worldwide. Pressurization became standard in commercial airliners, directly adapted from its military origins. Turbo-supercharging made high-altitude flight practical for all aircraft types. Remote control systems eventually evolved into modern fly-by-wire technology. In short, the innovations first proven in the B-29 transformed not only military aviation, but also laid the foundation for the modern aerospace industry. Captain Kazunori Onoda, who commanded a Ki-84 squadron during Japan's final defense operations, admitted the harsh reality. Our most advanced fighter meant nothing against the B-29 at altitude. Below 25,000 feet we could fight, but above that we were helpless. Pilots returned, demoralized, often without firing a shot. The psychological damage was worse than aircraft losses. We knew we were beaten technologically, which meant we were beaten completely. The B-29 campaign vindicated American strategic bombing doctrine by demonstrating the power of technological superiority. Altitude sanctuary allowed systematic destruction of Japan's military and industrial capacity without prohibitive losses. Strategic results were achieved without invasion, validating theories of air power. The delivery of atomic weapons succeeded only because the bombers were immune to interception at operational height. The campaign proved that decisive air power could come from technological advantage rather than sheer numbers, a lesson that directly shaped Cold War deterrence strategy. Japanese leaders recognized what this meant. Their inability to defend against the B-29 highlighted broader weaknesses across all branches of the military. Industrial production simply could not keep up with American output, especially under constant bombing. This realization weighed heavily on Emperor Hirohito's decision to accept unconditional surrender. With no way to prevent the aerial destruction of Japan, continued resistance became nothing more than pointless sacrifice. For the crews, the difference was obvious. Chief Master Sergeant Frank Morrison, a veteran B-29 crewman, explained, "The pressurization systems were complex but reliable if maintained correctly. Turbo-superchargers required careful attention but gave us power at heights where Japanese engines wheezed. Every system represented years of engineering development that Japan simply didn't have. We won through technology and industrial strength, not just courage." From the other side, Lieutenant Jiro Tanaka, a Ki-61 pilot who survived several failed interception attempts, remembered the personal toll. Each mission pushed us to the limit physically. Breathing was hard even with oxygen. Our hands went numb from the cold. Our eyes watered constantly from the thin, dry air. Then we had to watch helplessly as the bombers flew on while our cities burned. It was trauma beyond combat stress. We felt we had failed our ancestors, our emperor, and our people. Not because we lacked effort, but because our machines couldn't match theirs. The numbers tell the story. The B-29 program alone cost more than Japan's entire aviation budget for the entire war. American mass production created nearly 4,000 superfortresses with consistent quality and reliability. Japanese manufacturing, limited to smaller workshops and outdated methods, could not compete. They lacked the precision tools, alloys, and synthetic materials needed to replicate even captured examples. Industrial asymmetry magnified the technological gap and sealed the campaign's outcome. General Curtis LeMay's tactical innovations further exploited these advantages. Low-altitude night raids neutralized altitude defenses but instead relied on radar bombing, incendiary weapons, and massive formations. Whether at night or day, Japan could not counter the B-29's flexibility combined with its superior technology. Each Japanese adaptation was outpaced, every countermeasure outmatched. The campaign changed how the world understood strategic air power. It proved that technology could achieve results that once required massive ground armies. Industrial capacity itself became as decisive as battlefield tactics. These lessons fed directly into Cold War planning, where nuclear deterrence was built on the precedent of high-altitude strategic bombing. In the end, this study of Japanese fighter operations against B-29 raids highlights one inescapable truth. Technology was the deciding factor. Despite immense bravery, tactical ingenuity, and self-sacrifice, Japanese pilots could not overcome their aircraft's limitations. Pressurization and turbo-supercharging gave the B-29 an altitude sanctuary Japan could not challenge. Combined with America's unmatched capacity for mass production, the gap was unbridgeable. The B-29's operational superiority validated every dollar invested in advanced aviation. It showed that in modern warfare, technology can outweigh even the greatest displays of courage, skill, or determination. The final outcome of the campaign was decided as much in American factories and engineering offices as in the skies above Japan, setting precedents that would shape military aviation for generations to come.